Don't forget to check out the cool information and link for Altium Design software later in this video. Okay, so welcome back, and we're going to be looking at the actuating model. So this is the second half of the general automation model. And as such, we're going to be exploring the use of relays. So this is basically a mechanical switch that you can control from low voltage microelectronics, and it can be used to control much higher voltage devices. So you can turn on pumps and compressors and valves and lights and motors and stuff like that through this device called the relay. We're also going to be looking at how to control things remotely over Wi-Fi. In this case, it'll only be a LED, but it's good enough. We can replace that later on with anything that we want, really. And this is going to give us a good intro into what kinds of things we can make happen after we've analyzed sense data. Okay, so let's jump right in. Okay, so general automation model, as we described it, was you sense things as you normally would with your 5 senses. You analyze them, in this case with an MCU, not with your brain, and then you act. And in order to act, you need a whole host of devices called actuators, and there's a whole bunch that we're going to be looking at in future projects. But in this case, we're going to be sticking to some of the simpler ones, such as motors. Okay, so let's look at the first example. So we're going to be connecting a relay, and a relay is basically a connection between an acting device with a signal pin. So what we have here is a typical relay, and I'm going to be wiring this up. It's very simple. As you can see, we've got positive and negative and a signal cable. This is the signal cable, this is the low side, and this is the high side of the relay. So the low side is the 5 volt DC one. So we're plugging it into pin number 8. There it is, and now we simply give it power. So 5 volt positive and ground negative. Let me place this over here. We are not actually going to be connecting the high side to anything, but you can connect the high side pretty much to a whole host of common stuff like desk lamps. I've got one controlling a compressor. You can hook it up to motors. It's very common. Solenoid valves and stuff like that. So in this case, we're just going to see how the relay works, and in future videos we're going to look at how we can actually use them in more powerful circuits. Okay, so here is the code for the relay, and as always it is down in the description of the video, and I'm uploading the code right now, and you see the LED there, it's on, and then it's off. Okay, and I only put it in once, which means I put that code in the setup function. Otherwise the relay would just be going on and off continuously, and of course it's not that exciting if it's not connected to anything, but that is basically what the relay does. All we do is we send a digital write high to the pin we are interested in, and then a digital write low. So here is the Wi-Fi shield. This is very common. It's basically a prototyping shield that fits right over an Uno form factor. Okay, so we're going to be connecting an LED, and we're going to try to control this LED from our Wi-Fi shield. So let's do our regular wiring. I don't want you to see here, we're going to be plugging, this has the same pin out as the Uno, and pin 12 is where we're going to actually connect our LED. So instead of giving it 5 volts red, we're going to be giving it pin number 12. So only when we set the pin to high is it going to get power. The other end of the leg, which goes through the resistor to ground, is going to connect to the ground pins. Okay, there it is. So now all I need to do is, well, basically place the shield on top of the Uno. And because it has the exact same pin out, every single pin on the shield is going to fit right over the corresponding pin on the board. So there, nice fit. You got to be careful not to bend the pins. That happens quite often. Okay, and It's got some LEDs there that give you an idea as to what the status of the shield is. We're going to open the serial monitor, in this case, simply to look at debug code. So most of the time that we print stuff out to the serial monitor is mostly for debugging purposes. So in this case, we have the Wi-Fi shield. Oops, it's at the wrong baud rate. There we go. There. And there. So we can see some debugging messages in our serial monitor, and it is what we expect. There it is. It's giving you the IP address that it has obtained from the DHCP server, and we're going to use this IP address to let me switch over to the same network that the Wi-Fi shield is on, and that is defined in code. You'll be able to see that. And there we go. Okay, now it's going to load. It's going to find the Wi-Fi shield. There it is. It's loading, and there it is. It's changing the title of the tab. There it is. And this is what I have programmed the server to serve in this case. So it's a form field, and we type in a keyword that, depending on what the word is, it will carry out a certain function. If you look at the LED, there, it's sort of turned on. It's very faint. Okay, so it's on, and it's kind of faint. I don't know if you can see it, but let me go ahead and get a close-up on this. Yeah, there it is. Okay, so it's on. Alright, so now let's see if we can get this thing to turn off. Alright, let's take a look. Okay, so we can view the debug messages in the serial monitor. As always, you can see the keyword Coco, which sends hi, and now we're going to send off, which is the keyword to send low. And let me rearrange the windows so that you can see that data coming in as we punch it into the browser. Okay, I think we're ready, and yeah, so here we go. We're getting ready to send keyword off, and we have the serial monitor off to the left or to the right, and here's off, and you can see the data logged into the serial monitor right there. There it is, and the LED is off. Okay, and okay, so that is how we can send commands to and from devices over Wi-Fi using something like this Wi-Fi shield, which is much more convenient. Or you can also work with much smaller projects, much smaller modules. For example, there is the, I believe I mentioned it in previous videos, the Explorer model, which is the ESP8266, incredibly popular, not only because it gives you Wi-Fi access, not only because it is an incredibly small module, which makes products very portable, but also because it actually has a built-in microcontroller itself. And if you learn how to program it, and it uses the same code, pretty much, you can use the Explorer by itself. And that's going to get us into the realm of Internet of Things, where we want to have hundreds and thousands and millions of sensors and devices transmitting data, all interconnected themselves. So basically, we make things smaller, but we also make them smarter at the same time. And you go from just having a light bulb to having a light bulb, which is also maybe a speaker, is also maybe a server, is also maybe a temperature sensor, etc., etc. And it can do all sorts of cool stuff because we can fit so much functionality onto such a small package. Alright, so let's take apart the shield. And gotta be careful when taking them apart because, as I mentioned, those pins are very delicate. Let's take apart our LED example. We're not going to be using this anymore. What we are going to be using is this guy right here. So this is a Bluetooth module. It's model HC05. You can see the pin out right there. So it's got VCC and ground, and it's got something called RX and TX. So Wi-Fi and Bluetooth and many of the radio and all the communications modules use an RX and a TX
pin. And the R for receive and the T for transmit. This is important because it follows the same protocol. The VCC and the ground always go to the 5 volt in this case, and 0 volt ground. And the RX and the TX are the important ones here. And they connect to the Arduino in the following way. So you have the receiving pin on the module going to the transmit pin on the Arduino. And likewise, the transmit pin on the module goes to the receiving pin on the Arduino. And the grounds are the same. They're shared. Okay, so once that's done, let's go ahead and plug in the USB cable, and we see the module has power and it blinks very fast, which means it's ready to pair.
Okay, so let me introduce Altum Designer. Why? Because we're building all these projects and the idea is to make a product we can sell. After all, the only thing more satisfying than a working Arduino project is a profitable one. Nowadays, you can have your prototype or final designs printed by a professional PCB service. All you have to do then is make a cool case for it, slap your logo, and ship your products. Altum is a software that lets you drag and drop your designs onto a graphical user interface and automatically route all the connections for you and even send it off to get printed. Whether you're a freelance designer or part of a multi-company team, Altium has you covered with electronic and mechanical design, online collaboration, and even connection to manufacturing. Altium is the most trusted PCB design system with over 35 years of innovation and development. So when you're ready to make some serious money, Altium takes you from the idea to product faster and without the hassle. Download a free demo and try it today. Use the link in the description below for this video. So this is what the connection looks like, and you can pause this and come back to look at the connection, the wiring diagram. So this is what we end up with. Okay, so here is our phone, and we have a list of devices that are available, and very quickly connects, and there it is. You can see it is now blinking much more slowly, about once every 2 seconds, okay, which means that it is paired with another device and connected, and on the screen of the phone we can see that it is connected as well.
Okay, so they seem to be connected. Let's see if we can send and receive. So I sent the word hi to the Arduino. The cables seem to be the other way around. Sorry about that. That's why I put up that slide where it's important to always keep in mind that the RX and the TX switch around from module to microcontroller. So I fixed the cables now, and we should be able to send data from the phone to the Bluetooth module to the Arduino. So hi Santiapps. I'm going to hit enter to send, and there it is. It sends it, and because I programmed it to echo back everything that it sent, you could see everything that it sent on the actual phone. So what you saw scrolling up was actually the Arduino sending back everything it received through the Bluetooth module to the phone. Okay, so now let's see what it's actually programmed to do. So I'm going to type the number 1, and there it is showing up on the serial monitor, and it writes down open wide on the phone. And I'm going to send the 2, and there it is on the serial monitor. So it is receiving the data that we want it to receive. So let's go ahead and hook up the motor. Alright, so we're ready to actuate. Here is a servo, and it has 3 cables, VCC and ground, and the signal cable. Signal goes to the Arduino pin that we want to send the act command to, and our servo is ready to receive commands. Let's just plug in the, I need an extra cable for the ground here, or for the 5 volts, sorry. I'm going to take that from the module, and we're ready.
And instead of making that complicated connection over to the Bluetooth, I'll make it over to the OP, and then the servo spins. Just that's what it's meant to do when it gets connected. And see, now when we type in the 1 and 2, the servo moves as expected. One goes in one direction, 2 goes in the other direction. 1 goes open wide, and 2 goes close. And we can program it to do pretty much anything we want it to. That's just what it was programmed to do in this case. Okay, so we can now control lights remotely using Wi-Fi or motors.
Okay, so let's look at consumer devices. So,
what we have here is a lazy bone, a relay board, and a sensor that we're going to use towards the end. Okay, and we have here what's called a motor air. Okay, so let's take a look at these devices one at a time. So in this case, we saw the relay, and it had a low side, which was the 5-volt DC, and it also had the high side over here, which is where you connect it to the object you want to control, the actuator. In this case, there's actually, first difference is that there's actually 4 relays instead of just 1. But if we line this up, the high side, here's a relay, and there's 4 of them on this board, but the high side is over here, which is like this high side, where you connect the lamp or the motor. The low side, which is the one you're going to control digitally, in this case, there are no cables, as you can see. It's over here. It's actually a Bluetooth module. So what we can do with this is we can send Bluetooth commands from an Arduino and control all 4 relays. So this is much more flexible, much more robust. In this case, you're kind of limited to the commands that you can send, and you can program it in different ways, but it's easier to use. It's more plug and play than anything else. It's much like this thing and this thing. Let's look at the motor air first. So this is pretty cool. This is kind of like an L293D, except that it only takes 2 motors in this case instead of 4. And it has a Bluetooth chip right in there, much like this one over here. And you can plug in 2 motors in this case for a 2-wheel drive car, and you can send Bluetooth commands from a phone and send whatever you want and control the car. So this is also, it's almost pre-programmed, so it's limited into what commands you can send, but it's much easier to use. This lazy bone is actually, I have one over here connected to a power cord. So there's one of these relays inside, and much like this, which is 4 relays that you can control through Bluetooth. In this case, this lazy bone is right here. It has the connection from a extension cord that I cut out. So, like I said, there's a relay inside, and there's a low side and a high side, except that the high side in this case is what we can see is the cables, which interrupt the circuit, but the low side is actually inside. It's a Bluetooth. It could also be Wi-Fi, but in this case, TinySign sent me this Bluetooth one, and this is very easy to plug and play to a lot of devices in your house, and control them from a phone, for example.
okay, so we looked at relays, we looked at Wi-Fi shields, motors, LEDs, and in the end we looked at more consumer grade devices such as the lazy bone and the motor air, which come pre-programmed with certain commands that you have to send them in order to make them active or not, and they usually come with some mobile app or some kind of software interface that is used to send those commands. But in the end, they are all actuators. And the difference is that consumer-grade devices such as the Nest devices that you see for controlling air conditioning or the locks are made to be controlled by a mobile app, which is a lot easier to do than through commands from an Arduino. Alright, so I hope you enjoyed this video, and look forward to seeing you guys in future videos. So don't forget to like, share, and subscribe. See you.